So this is anti-relativity, lesson 6. It's carrying on with the derivation of the Lorentz transformations from the previous lesson. There are lessons in special relativity, and the aim here is to try to counteract that and give lessons in anti-relativity. And the way to do that is to point out what is being taught in relativity lessons is nonsense. Over the years, the teaching of special relativity has been to pile on more nonsense. So going to contrast how the teaching has changed, and taken as example a 1982 relativity book with how it was revised later in 1991. So here's the two books we're contrasting. It's Introduction to Special Relativity by Wolfgang Rindler. The original publication was shown there on the left hand side, and the second edition of the book is shown on the right, which was done in 1991. So I'm mainly going with the second edition of the book and pointing out when it's different to the first edition. And so the aim of that is to show the methodology of teaching relativity is to move the goalposts. Some nonsense is said, but that is never enough, and some extra nonsense then gets added later. So moving goalposts is really supposed to be a logical fallacy, but the people who believe in relativity don't seem to mind that that's what they're doing. So moving goalposts is to make changes to the theory. And so I'm picking up from part 1 here, and this is what you got from part 1. It's given the Lorentz transformation equations, and hopefully you can understand what those equations are. And it's saying it's not a foregone conclusion, but I'll go into details about that, just adding assumptions at a whim when it does that. And so carrying on with edition 2 of the book, it's going to say all this about how you're connecting a frame S with a frame S prime, and it's using coordinates such as X prime, Y prime and Z prime. And Rindler is going to use differentials, which is going to be dx prime, dy prime and so forth. It's unfortunate I didn't want to get into that complicated maths of using differentials, but he's bringing it in. But hopefully everyone following these videos will understand that maths from here on. I'm going to have to assume they do. So the book says, accordingly, the Euclidity of S prime is equivalent to the validity of this following equation 6.11. And by Euclidity presumably means Euclidean relation, which would make that a Euclidean type equation. But the book is not really going into enough details about Euclidean geometry, and that's one of the things these relativity books do, is they don't go into enough details about certain things. And it's making this confusing word Euclidity, whatever that's supposed to mean doesn't really going to tell you, but just presuming it means Euclidean. And so, but the rest of the sentence is, so the rest of the sentence goes on to say along any like signal. So that equation 6.11 is supposed to apply to any like signal. Now, if we're supposed to be dealing with Euclidean geometry here, then Euclid was about 300 BC, and he wasn't dealing with that. So it's making things a bit confusing by trying to make out it's Euclidean geometry. So it's a bit of a mystery here as to what was really being talked about, but we're going to pass on that. He doesn't explain things properly, and there's a complain a lot, these relativity books don't explain themselves properly. Anyway, the book carries on to say, but one can easily verify that equation 6.10 imply the very fundamental identity, which is shown here, of equation 6.12. And equation 6.10 was the following, which I've shown again. And I'm going to write out equation 6.12. So this is just me writing out the equation which has been given to us. And so you note on the left hand side you've got dashes over t, x, y and z, and so that makes it different to when there's not dashes on it, which is on the right hand side. So why can't there be a dash put on c as well? So you would be a c dash on the left hand side. So that the C on the left hand side is different to the C on the right hand side. Relativity texts such as Mindler never go into details about that, and so leave everything obscure as usual. If did that, then wouldn't need the Lorentz transformations question mark. Right. Anyway, edition 2 of the book carries on to say, and thus the light signal, since it satisfies the equation analogous to equation 6.11 in S, will satisfy the equation 6.11 in S prime. This completes the proof that S prime is indeed inertial, and that's within the coordinates x prime, y prime, z prime as the Euclidean coordinates. And which my comment is, which seems nonsense. Why talk about equation 6.11 when just now we're only talking about equation 6.12? And what proof, question mark? Why not deal with, as I pointed out earlier, having it as C prime, putting the dash above the C to make C different in the left hand and the right hand side of those equations, and numerous questions like that. And of course questions like that are not dealt with, which is why I'm complaining about these relativity books. So edition 2 of the book carries on to say, as a byproduct of this argument, we have now established that any frame in uniform translatory motion relative to inertial frame is itself inertial. And my complaint about that is it's a byproduct from something that did not make sense, and hence the byproduct itself does not make sense. So something that doesn't make sense leads to something else which does not make sense. So it's the usual method of relativity text to just keep piling on, saying more and more things that don't make any sense. And so edition 2 of the book carries on and says, importantly, equation 6.12 also establishes the full consistency of Einstein's law of light propagation, namely that light can travel at constant speed c in all directions in all inertial frames. In our derivation of the Lorentz transformation, we use this axiom only for one special signal. And my complaint about that is does not say how. Does not say what the math for Einstein's law of light propagation is in terms of the maths. So you ideally really needs to show what the equation would look like without that law, and contrast it with what the equation would look like if it had that law. And so it's presumably it's something to do with this dash over the C. So in that equation on the left hand side, if you put the dash over the C, making C dash different on one side to on the other side of the equation, then that is the difference. If you're making them equal, then that becomes Einstein's law of light propagation, presumably. But the book is not telling you that. It's just leaving it all the usual ambiguous nonsense. And so footnote edition 2 gives a footnote, and it says so called because they were originally derived by Lorentz as the transformations that formally leaves Maxwell's equations invariant. And what it's referring this to is the Lorentz transformations. That piece of mathematics is named after Lorentz. And Lorentz did have a theory dealing with them, but the book is omitting dealing with what that is. So just not giving enough details, again, as per usual. You've got a theory from Lorentz, and he's using the Lorentz transformations, and we're not dealing with that, we're dealing with what Einstein is talking about when he deals with this Lorentz transformations. So going back to this bit, in addition to in all directions in all inertial frames, our derivation of the Lorentz transformation, we use this axiom only for one special signal. And the question I have, my complaint, what special signal? And what's that supposed to mean? And it's just another thing that the book leaves obscure, so you can see what's going on here. The book's just making things obscure, saying things and not clearly explaining what any of it's supposed to mean. Addition to the book then carries on. One last thing that still needs checking is the full validity of our assumed XY or XZ reversal symmetry. Applied to the transformations 6.10, either reversal yields the inverse transformation. And what we're talking about here is the inverse Lorentz transformations. And everything else said just amounts to just more obscurity on that bit. Whatever's going on, it's just making it more obscure. So the book carries on to say the advantage of the above reversal symmetries in the derivation of the Lorentz transformation is that they do not involve V, when one has no a priori knowledge of the velocity dependence of the coefficients. But in future we shall find another symmetry more useful. Any relativistic transformation formula relating unprimed and primed quantities, that's from S and S prime respectively. So my complaints about there is it says any relativistic transformation formula. What are they? Question mark. We have so far been only dealing with Lorentz transformations. If there are any more relativistic transformation formulas, we have not been told about them. So it's just piling on more obscurity again. And so anyway, the book carries on and says any relativistic transformation formula relating unprimed and primed quantities from S and S prime respectively remains valid when V is replaced by minus V and primed and unprimed quantities are interchanged. We call this a V reversal. The reason for its validity is that the contemplated transformation must apply to any pair of inertial frames in standard configuration and for any V between minus C and C. So if we simply rewrite it with S prime as the first and S as the second frame, the V reverse transformation results. Note that this process this is the TOO, transforms the equation 6.10 into equation 6.13. And so the pass on that bit. Book carries on, it says, we shall here also mention the trivial but sometimes useful middle frame lemma. Given two inertial frames, S and S prime, there exists a third inertial frame, S double prime, relative to which S and S prime have opposite velocities of the same magnitude. We can picture it in the middle between S and S prime. Its existence is at once evident from continuity if we put S and S prime in standard configuration and consider the entire set of inertial frames in standard configuration with S. And so the book's not going to show the math to support that lemma, and so I'm going to pass. It's just going to say things, and it's not going to give the evidence for it. And so a lemma usually means a proven statement that serves as a stepping stone to prove a more significant theorem, but it's not given any evidence for it, it's just stating it. Just more nonsense from the book. Addition to the book then carries on to say, to end this section, we note that if a law of physics is invariant under standard Lorentz transformation and under spatial rotations, spatial translations, and time translations, then it is invariant between any two inertial coordinate systems, and so satisfies the relativity principle. And it carries on, it says all of this, and it's not showing the maths for any of that as well. Just more nonsense. The book carries on and says, in fact, Poincare transformations are precisely those that satisfy the identity of the equation 612 and contain no spatial time reflections. And so presumably the Poincare transformations are something you can use instead of Lorentz transformations or something like that. Book's not going into enough details again. So that's the end of section 6, in addition to now giving what edition 1 says. And so this is from edition 1. Edition 1 is saying it different to what edition 2 is saying. Let us see what modifications special relativity imposes on the Galilean transformations. And so in this earlier edition of the book by Redlow, he's going to say something completely different. He says the Lorentz transformations are supposed to be a modification of the Galilean transformations, or at least he seems to be saying that when he says let us see what modification special relativity imposes on the Galilean transformations. And how he's doing that, that's not clear. And that could be problematic to understanding relativity. I don't know how many think that special relativity is a modification of Newtonian physics. The book does not address that issue, so no wonder it's omitted from the update. Edition 1 carries on to say the following. An important first property of the transformation equations is that they must be linear, as are the Galilean equations. This follows from homogeneity, and that means it's another ad hoc arbitrary assumption being introduced without saying why. So edition 1 is saying something which is not in edition 2, and it's probably omitted because he suddenly noticed it's another ad hoc arbitrary assumption, which would add just more confusion. Edition 1 of the book carries on and says, for consider an arbitrary clock reading, and that's time, tau, that letter is tau, and moving uniformly in accordance with Newton's first law through an inertial frame S. Homogeneity requires that equal increments of tau, repetitive experiments at the clock, correspond to equal increments of the coordinates t, x, y, z, which we shall temporarily denote by x subscript I, where I takes on the values 1, 2, 3, 4. And then you've got a differential equation equal to a constant. And it doesn't explain why that equation is equal to a constant. But when you differentiate that equation again, it's supposed to equal 0. You cannot explain where all that's supposed to be coming from. Edition 1 of the book carries on to say, the same must be true in any other inertial frame with coordinates, and that's x subscript I, but now with the dash above it to make it prime. and it's writing that equation. And the question I complain about now is why must be. Just more claims without explaining why. Edition 1 of the book carries on, thus for any free motion of such a clock, the last term in the above line of equations must vanish. This can only happen if that equation equals 0, or if the transformation from the prime to the unprime coordinates is linear. And it's pointing out the person who's made that argument. But whether that person, why I was saying, it seems to be missed out. And it's not been adequately dealt with. So it's just another omission, something omitted from edition 2 of the book, presumably because he suddenly realised it. He's not explaining himself very well here. So edition 1 of the book carries on, another basic property of any pair S and S prime of inertial frames using identical standards of length and time is that each ascribes the same velocity to the other. And so my complaints there, well, that was not very clear as to what was meant, but it gives a footnote, and the hope is that the footnote will clarify things a bit. And so this is the footnote, what it says. For brevity of expression, we occasionally anthropomorphize frames, particles and other inanimate objects. And that clarifies nothing. So the method seems to be to just keep saying things which don't explain anything. Right. So the book is now saying this follows directly from the lemma of section 4, asserting the existence of a frame S double prime midway between S and S prime. So what it's saying now is referring back to what we were saying earlier, where things were not properly explained even then. So it's just piling on more obscurity. Edition 1 of the book carries on to say the following. Now consider any event, and that's a P, a funny shaped P, and a neighbouring event with another funny letter close to that funny P in S and S prime. And so it's bringing in this dubious law of light propagation, so going to pass. It's just bringing more obscurity into things. So what we have is the book leading now to equation 6.6, and it gives a footnote with that, and it says, from this identity, another standard argument for the linearity of the transformations equations can be made, and it's giving you that as an exercise. And so you're supposed to work out that identity for yourself. And so what was just nonsense. It's bogging itself down with things, and you're supposed to work it out for yourself. And so in this bit of what the book is saying in edition 1, it's talking about using the chain rule, and that's a bit of mathematics. And so before even dealing with relativity, you're supposed to know mathematics such as the chain rule. And so it's highlighting one of the problems that any relativity text has, to presuppose that the reader has a certain amount of knowledge beforehand, before even approaching looking at relativity. So it's telling you something follows from the chain rule of differentiation. So you're supposed to know that from earlier in your scientific education. Anyway, edition 1 of the book carries on to say, the reader may now be tempted to shortcut the argument by asserting that two polynomials which share their zeros must be multiples of each other, and then so forth. And so I want to pass for what follows, because it's just lots of maths. Other critics of relativity have complained that the relativity of mass does not make sense, but I don't want to go too far down that route. I pointed out the issue of what's being said doesn't make any sense. And so the next issue is the maths doesn't make any sense, but that's been dealt with by other people. Edition 1 carries on. It gives you this mathematics of what he calls the polynomials and so forth, and I'm passing on that. And so the book carries on. It's still going to give you more mathematics, and I'm passing again on that. And it's even more mathematics, which I'm going to pass. The thing to note is this mathematics is not in the updated version of the book. So for some reason, the author decided, oh, this math is not really needed. I can omit it in the update. And there's even more maths here. And it carries on, even more maths. And even more maths, which I'm going to pass, this is all in edition 1 and excluded from edition 2. Same again, more maths to pass on. And so it's even more maths here. So we've had a large amount of mathematics, which is in the edition 1, which is not in the updated edition 2. It was a great deal of maths. So why wasn't the original edition of the book and removed from the update? I suspect something might have been very wrong with that mathematics. The author suddenly realised, oh, that mathematics doesn't make any sense. So he removed it from when he updated the book. But of course I'm passing on it. Why start looking at a lot of maths that doesn't make any sense? So when he says Lorentz transformation equation, he gives a footnote. He says it's so called because they were originally derived by Lorentz as the transformation that for normally leaves Maxwell equations invariant. And at this stage I'm too weary to complain again about things being said which are not properly explained. So this is an edition 1 of the book which gets omitted, but edition 2 of the book says something similar and it still leaves things unexplained. Anyway, now back on track to complain about the things I want to complain about. Edition 1 carries on to say, it is now easy to verify that this transformation indeed respects all the axioms we have assumed. Moreover, it satisfied the so-called group axiom, which must therefore be already implicit in the others, which we have not yet formulated, but without which the theory could not be consistent. It will be discussed in the next section. And my complaint once again, we got something introduced, something here called the group axiom, and we're not being explained properly about it. And it's supposed to be being put off until the next section. Edition 1 of the book carries on to say, if a law of physics is invariant under this transformation, Lorentz invariant, and under spatial rotations, spatial translations, and time translations, then it is invariant between any two inertial coordinate systems, and so satisfy the relativity principle. And my complaint here is what's it mean by the law of physics, and can just be arguable. He's not going into details about that. It's the usual say something and not explain yourself properly. So edition 1 carries on to say the following, which is not in edition 2. Once again, I thought it's easy seeing that the general transformation between two inertial frames whose coordinates are standard but whose configuration is not consists of the following properties. And that's supposedly all done in the maths earlier, but I have problems with that. If that was really what edition 1 was showing, then why would that maths be omitted in the update? So edition 1 of the book carries on to say the resultant transformation is called an inhomogeneous Lorentz transformation, or a Poincare transformation. So suddenly I'm complaining here about it's introducing new terminology. If it was generally dealing with Poincare transformations, then Poincare was dealing with those Poincare transformations in his theory. And there's no mention of Poincare's theory. It's just another of the numerous things being omitted. So this is in edition 1, and suddenly he decides to omit saying this in edition 2. And it's probably because he's not going into sufficient detail again. You've got Poincare's theory and he just wants to omit talking about it. Carrying on with edition 1, it says, since each link in the chain of transformations is linear, so is the resultant transformation. Poincare transformations also evidently satisfy equation 6.6, since standard Lorentz transformations do. And so when it says evidently, it's presumably admitting it did not deal with that issue earlier. It's just making out that it's evidently that's what happens, even though it's not go into details about that. Anyway, that brings us to the next of this section in Windler's book of first and second editions. The next section deals with the properties of the Lorentz transformations. But I will bring the lesson here to an end because the derivation of the Lorentz transformations don't make sense. So why look into the properties of them? So what we're going to do is now wrap things up with conclusions. So, as pointed out, this relativity textbook by Windler does not make sense. It does not go into sufficient explanation, as I've complained about a lot. And it's not just me who realises this with these textbooks. Many people have realised it. And I contend that many people who go on to these relativity courses realise it does not make sense to them and they give up, leaving the course. And that leaves the people on such courses as those who think relativity makes sense, because they're the ones persevering with it. For those of us who ask such relativity believers questions, it does not help us, because taking as basis these relativity texts that don't make sense, the relativity believers will build upon that basis and just carry on saying things that don't make sense. So the relativity believers just believe things that don't make sense. They recruit people through the education system of more relativity believers who are prepared to accept things that do not make sense, while others drop out that process. So that's basically it. That's the end. That's my grievance at these relativity courses. They're just saying things that don't make sense, and the people who want to carry on with these relativity things, well, they're going to just say things that don't make sense. And they're trying to recruit more people in via the education system to say the same thing, of saying things that don't make sense. Thank you. The end.